All right, why are you making noise? Let's see what happens. Okay. So let's see, 23, 27. All right, sure, they're good. This will be a nice little review of what we did roughly 3 million years ago. 23, that's what it feels like anyway. All right, so what is it that I need to do with this first? Yeah, you got to isolate the radical, right? So you can kill it. So you add 3. Yeah. Let me show you something real quick, by the way. You got to show me work and all that kind of stuff, but it's nice to step out of the problem. What do I take the square root of to get 7? 49. And what do I add 1 to get 49? 48. So I know the answer is going to be 48. All right, just look at this. But if we do the steps, in case I can't do that in my head, do the steps also so you show me what the hell you're doing. But it's nice to know ahead of time what the answer should be. Square both sides. I like it. Why do you square both sides? Good. So it's not still squared. Don't foil this poor little dude. Right? He broke the wall down. He's dead. Laying on the ground. I say, oh, thanks, man. And then subtract 1. X is 48. And you have to check just to make sure nothing freaky happens. 48 plus 1 is 49. Square root of 49 is
7.
Minus 3 is check. Yay! I like it. So that's one type where every variable is contained in the radical. There's no variables outside. Right? So that's a nice, very straightforward problem. Problems get a little bit more difficult when there's a variable on the outside. But again, the same idea. Is my radical isolated? What's with the radical? The radical is isolated, right? This radical is not isolated because there's a minus 3. Once I do it, then the radical is isolated. Is there anything with this radical x plus 6? Is there anything with it?
No.
No, so it is isolated. So what can I do to both sides?
Square.
Square it to kill that square root. I like it. And I desperately want you guys, if I had this problem, what would I do first?
Multiply by 5.
Yeah, I would multiply by 5. Do you guys see that? Because the x plus 6 is stuck over a 5. So I'm going to do the operation that will unstick it. You guys kind of get that? So here, where's the x plus 6 stuck? In there. So I'm going to do the operation that's going to unstick it. Bam. Now, what do I do with this?
X subtract equals 6.
No.
Get all the. You make the equation equal 0.
Are my x terms like terms?
No.
No, so I can't do it like the old days. I got to do the new thing. One of my terms is squared. So I have to get it equal to 0. And then you can factor. So it looks like this kind of thing sneaks up on us and we don't take a second to think about it. This happens a lot in problems. Just because we left this section where we learned this in the past doesn't mean this idea is never going to come back up. Now we're realizing I can start way up here and do a lot of shit. I got to know what the hell to do when I get here. It could happen anytime. It's because I can't put my x's together, so I need a different way to solve it, and we developed this different way to solve it. So how do you factor this?
X minus 3 and x plus
Kick ass. So x is either.
3 or 2.
Those are my possible answers.
No.
It's x equals 3.
I like it. Those are my possible answers. I got to check them to see if they work. Normally one of them will, one of them won't, but it's possible both of them work, or it's possible neither one works. So I'll leave it up to you to plug a 3 in and plug a negative 2 in and see if they both work. But just for example, when you plug a negative 2 into the original, what happens? Plug a negative 2 in. Square root of 4 is 2. And on this side, is 2 equal negative 2? No. So I know this is happening. I know people are like, this is hard enough already. I do everything perfectly right, and math gives me a wrong answer. Screw you, math. But math, this is the only way math can tell us oh shit, 3 is the only answer. I mean, there's no way for math to sit up and say, hey, if there was, it'd be freaky as hell. I don't know what it would look like. But if x is negative 2, then radical equals negative. That can't work. I don't know until it tells me, check this. I mean, once we squared, what does negative 2 become? If I do this step, does it work in this step? I really want you to, it doesn't work when I plug it in the original. That's the official way to check something. But if I plug it in the next step, does it work? Negative 2 plus 6 is 4. What's negative 2 squared?
4.
Is that true?
Yes.
Yes. So math answered this because we did something we didn't realize, lost information. If x is negative, x squared is positive. I changed the sign. I didn't know until I'm here and I go, oh, that doesn't work. All right, there. Don't get mad at math. It's the only way it has to tell me something's wrong with something. Is for me to plug it back in and go, oh shit, something's wrong. All right, maybe. Sure.
Alright, 40.
Oh, all right. That one looks a lot like this one, right? This one, I don't want to do too much on this one. Let's see. It looks like minus 2b plus 1. Equals b, right? You see what I mean? It's the exact same problem as 27. Square root of something equals variable. Well, what tells me what to do here is I got my b stuck inside a square root. The square root is isolated, so I can go ahead.
Square.
So you get b squared minus 2b plus 1 equals b squared. That's as far as I'm going to go. The rest of it should be pretty easy. That one's really nice. I don't have to do like I did on that one because what happens to the b squares? Cancel. I don't have unlike b's. I have just one b term left. So I can solve like the old days. You have to check your answer. Yes, no, maybe so.
Yeah.
Okay. Yeah.
Oh, on one problem that it was 1 minus 6z.
One minus 6z
To the third.
to the third.
Equal to negative 64.
Do you remember what section that was from?
10/6.
Okay.
Yeah, there's a problem with
I got you. Because it makes sense that if, and it's to the third power, or, yeah, it's to the third power, okay. If I square to kill a square root, I would square root to kill a square. In this case, what am I going to do to kill a cube?
Cube.
Give it.
That sounds like some weird old show. To kill a cube. I'll just take a seat. Chris Hansen. All right. No, yes? So cube root to kill the cube power. The same way that a second power kills a square root. This is kind of the opposite of that. If I have a power, I can kill it with a root. If I have a root, I can kill it with a power. So then these go away. So you get 1 minus 6z. What is the cube root of negative 64?
Negative 4.
Negative 4. And then that's easy to solve. Maybe.
70.
Let me make sure. Okay.
Let's do 45.
Okay. 45 is a more interesting question. And 70 is okay. 70 might be a good place to remind you guys how to do this in the calculator and to make sure that that actually works. Okay. So 45, I'm going to do one that's like 45, just because I've been doing too many of these problems for you. I like it. Cool. Ooh, that's yummy.
Do you tell them what the square root, or is it can't do it because there's too many?
So, what is it I keep saying is your first step in a radical equation problem? Isolate the radical. You can't do that here, can you? I can at least separate these two. I really want it to make sense. If I square both sides now, I can't just say that this is x minus 1 plus x plus 4. That's not true. What have I not done correctly? Well, how do you square something plus something? You write it twice and you FOIL, right? That's what that is. Do you guys remember that? Wasn't that long ago? So if I said, what's x plus 1 squared, and somebody told me it's x squared plus 1, what would you say to them?
Yeah.
That's bullshit. Bullshit. Because they forgot to FOIL. They lost the middle term. Do you guys see that? That's why, if I can, I isolate the radical so I don't have... Can you imagine? Good Lord. Can you imagine foiling this kind of thing? I really want you guys to understand. You're overly optimistic. You say, well, that kills that, and then either you leave that alone or you make it 16 or something. But of course that's not how that works. You'd have to write this twice. And then FOIL it. Why do you have to do it that way? Because that's the way it works. The other way is quicker. Quickly get to the wrong answer. I don't want that shit. You guys understand? That's why we isolate the radical when we can. So what do we do when we can't? We at the very least, I want to get one of these on the other side. I don't want two radicals. Can you imagine? Some guys might realize this is not that disgusting. But it's a little more disgusting to FOIL this than to FOIL one radical in a number. I don't know if you guys agree or understand. No, yes? So the main difference between this problem and the problems we were doing earlier is there's two radicals. So what does that mean? It probably means I'm going to have to square twice at some point. All right, so here's how this kind of problem works. If I move this over, doesn't matter which one, I'm just going to move that one over. So at least I got one of my radicals isolated, right? Not icicles radiolated. That's what I was about to say. Going to radulate your icicles. So now you can square both sides. Here, I'll do half the work. I'll do this side. Now you guys take a minute and try to do that side. Write it twice so you don't forget anything. You should end up with 3 terms at the end. FOIL this bad boy out. Don't let the problem intimidate you. All right. There's one little thing in here I want to see if you guys noticed. So 5 times 5. 25. And real quick, my Math 90 people, I've said it a few times this semester, this is what I mean when I say the process doesn't care what's in there. How do I multiply binomial times binomial? I FOIL. The process doesn't change because there's a radical with stuff in it. It doesn't change. 5 times 5, 25. 5 times this thing, 5 this thing, right? 5 times this thing, 5 this thing. And what's minus times minus? Good. Plus, rad x plus 4 times rad x plus 4 is? X plus 4. I love it. Half of x plus 4 times the other half of x plus 4 makes a whole x plus 4. Oh. Sorry. So whenever you have 2 radicals in your equation, this kind of thing is going to happen. Do you see, I squared once and I killed 1 radical. But don't I still have, I have 1 radical left because these 2 can, what can you do? So you got 25 minus I got negative 5 of these minus 5 of these is negative 10 of these. Come on now. Negative 5x minus 5x is negative 10x. Negative 5 stuff minus 5 stuff is negative 10 stuff. You can start to see that this is a single thing. So if I have 5 and 5, I got 10 of those things. And then plus x plus 4. So I've simplified both sides as much as I can. Now I start to do what?
You can put the 25 and 40 in the tension.
I love it. I guess I was lying. I was lying. I'm sorry. Now what can I do?
Bring the X over.
Good. Get the x's. Yeah. Now, what do I? Looking at this with fresh eyes. If this was the original problem, what part of this do I focus on?
The radical.
I want to get the radical by itself. I love it. Right? I don't care that I've already done a lot of work to get here. I do, but I don't. It doesn't tell me what to do. It doesn't matter what I did. I just look here and go, I got a radical piece, I got to get it by itself. That's what I always do when I'm trying to solve an equation. It doesn't matter that it came from me doing stuff. I got a radical, I got to get it by itself. So subtract x, subtract 29. I get negative 30 equals negative 10. Let me pull this up here. Is the radical by itself yet?
No. And
Divide by negative 10. So you get 3 equals this. Look at that, that's nice.
Square again.
Square it again. So I knew I was going to have to square it twice because there's 2 radical elements in there. So get 1 by itself. Square, meaning this side you have to FOIL. Then get the other one by itself. Square both sides again. Now what's really nice on this particular problem that doesn't always happen is my x's went away. Right? It's always nice when you're nice. If there would have been an x still here, I would have had to FOIL this out, right? That's a little bit uglier problem, but again, we know how to handle that if it happens. I want to see you chuckle who can relate to my past life experience. So then, what do you do here? Square. So x equals 5. Now you definitely got to check. Good Lord, we squared twice. There's so many places that things could have screwed up. Does 5 work? 5 minus 1 is
4.
square root of 4 is 2. 5 minus 4 is 5 plus 4 is 9. Square root of 9 is 3. 2 plus 3 equals 5. Check. No more, Jeff. Whew. But you guys get the idea. If there's 2 radicals in my problem, I'm probably going to have to square twice at some point. You won't have more than 2 radicals in your equation. Don't worry. You're like, well, if there's 3. Well, if there's 3, then you're in a different class. Not in my class. All right, maybe.
I killed the class off with that one. No one heard you say, man.
I killed him? Oh, man. That was the delayed reaction. Alright, I don't know what I wanted to do. Does the idea make sense? If there's 2 radicals, kind of square twice. The fact that the very first thing we did is the same thing we always do. We isolated the radical, but now I say isolate a radical, because you can't, there's more than one. Square both sides, there's still a radical left alive. Okay, get him by himself, kill him. That's the process you go through when there's more than one radical in your equation. Maybe, possibly, could be. Okay. Anything else from homework that I can lose you guys on?
70 again.
What, is that the one we just did? No. Oh, okay. All right, let's do that. Let's remember how to use the calculator. And then we got to get some new stuff. Okay. Come to life. Hey, look at that, man. Well, that does a lot. All right. This. Yeah, screw it. Well, like, fun. When you got here for summer, you saw this. Well, no, just beginning. Okay, so we're looking at problem number 70. So the first thing is two things. It has a cube root in it, right? If you look at number 70, it looks like this. Cube root of x plus square root of x equals 3.43. 3.43? Now, I know the answer is really obvious, but no, I'm joking. Sorry, I have no idea. It's got a cube root in it. The calculator has a cube root button, but it also has, just to remind you guys, it has a anything root button. So there's a cube root button. But another way to do cube root is to say, so how do I do this graphically? Let's start there. How do I do this graphically? I probably want to do what with these? And when I say these, there's only one equation, but there's two sides. So if I graph this side and graph this side, the answer will be where those graphs meet, which is where they're equal to each other. That's why it makes sense. It's the visual interpretation of how things are equal to each other. It's where they cross. Okay, maybe. So if I put in, oh, now you're waking. If I put in, let me do it this way. Clear that. So if you have your graphic calculator with you, I'm going to try this out. I can do the cube root like this. There you go. See, it put it together for me. It's got a cube root button, but if you need a fifth root, you hit 5, and then you hit that extra root button. It makes it into a that root. Cube root of x. Hit the over arrow to get the hell out of there. If you have the older one with the parenthesis, just close the parenthesis so you're out of the cube root. Plus square root of x. Well, that's easy enough to do. That's one side, and the other side is 3.43. So please don't come up to me and ask me where the equal sign is. The equals is the idea. This is one line, one curve, this is the other, and I want to see where they meet. You don't have to put an equal sign in anywhere. Now, who remembers whenever I put new functions in, I should hit what? To make sure that I just start off with a normal window.
Trace.
Zoom 6. Standard window. So see where we start here. There's that, and then there's that. Hey! So where's the answer? Where they meet. I like, that's awesome. It's right there, John. You see it, John? All right, cool. Why does this thing stop here? Why does that blue line stop there?
It's a positive number.
Why has it got to be positive? Because, yeah, when I'm talking about real numbers, I can only use positive or 0 for square roots. How do I find this point?
Calculate.
Yeah, the second trace to get to calculate. Remarkably enough, the fifth one. Put the cursor on your answer. It asks you 3 questions, but if you only have 2 functions in there, the first 2 questions are kind of silly. So just put your cursor on the answer. It's going to say first curve. I hit enter. It bounces to the next curve. So you hit enter, and then asks you your guess, and I'm like, well, I've been on my guess since the beginning. Enter. And there you go. You get 3.6 blah blah blah. Which one of these is the answer?
3.3.
No. 3.6 blah blah blah, right? What's this equation have in it? X's. So don't even tell me the y. Don't even tell it to me. It's what they both happen to be, but I want the x value that makes them both the same number. I don't want to know what that same number is. I want to know what the x value is. So you would just write x equals 3.6, blah, whatever they would tell you to round it to. You guys cool with that? That's beautiful. I don't know if you realize what just happened. If I let you use your graphing calculator and everything, you can check every single equation you do if you have time. This one, you can put that into y1, that into y2, do this thing, make sure you got the right answer. Do you understand what I'm saying? That's insane. Some of you maybe do, okay? It's an awesome thing to be able to do. Okay, I'll stop. Anything else about the calculator while I have it up here?
Wait, how did you do the cube root again?
So, the cube roots you can do quicker. You can just go to math and then there's a cube root button. But if I had to do like the fifth root or something, get out of there, just rah. All right. So if I did I have to do 5 math. I call this the throot. Right? Sort of like an alternate Guardians of the Galaxy. 5 throot. So 5 throot, fifth root of something. That's how you make a root. You put the number in first, and then you hit that throot button. I like some of you guys like that, Joe. I liked it. I haven't learned all my lines yet for this root part. Root. All right. Cool. Anything else while that's up there?
My line didn't come up right.
What's up?
I don't know why my line didn't come up right. Never came up to the 3.6.
It doesn't like the batteries. No, Joe. Oh, why did you get out of there?
I don't know. I was trying to do like
Oh, right there. Right there. See how it's telling you you're inside the cube root still. Get over and get out of it. There you go. Cool. Whenever if you're up in an exponent, you got to hit over to get out of the exponent. Yeah. I like it. Okay. So let's get into some new stuff. Getting some help to stay awake. I like that. All right. So we have one last section in chapter 10. I'm sort of going to attempt to tell you the complete picture. Let's see what we think about this. There's so many ways to introduce this. And I've already talked a little bit about imaginary numbers and the fact that that's just an unfortunate name. We could have called all negative numbers imaginary because they were accepted just as well. So let me try a couple things. We got to start first off with just the basic definition. Before today, if I said this, what is this? You're allowed to say either undefined or not real. After today, you must tell me this is I. Right? And really, the only reason we call it I is just so it's easier to write. It doesn't look as gross. So it's better to write this than it is to write that. Now, it looks better than this. It just does. If you don't agree, I don't know what to do with you. You're wrong. So, hey, all right, don't try. I'm not. So that's the basic definition of the imaginary part of a number. Is the square root of negative. So for example, what would the square root of negative 4 be? What do you think that would be?
4i.
Careful.
No.
Square root.
2i.
2i. And really, the way to see that fully blown out is, can't I break this up as the square root of 4 times the square root of negative 1?
Sure.
Sure, Jeff, you can do that. You can do whatever the hell you want. Square root of 4 is 2. Square root of negative 1 is? I. Be really careful. I is not negative 1. The square root of negative 1 is I. Right? That's who I be. I love grammar. Just goes out the window when we do this stuff. I'm trying to figure out which way I want to go. Okay. So I'm about to show you something I normally don't show, but I just want to see how this is accepted. You're like, yeah, guinea pigs, whatever, Jeff. If I multiply something up here by a negative, the answer ends up where? So that's a weird question. So if I did 1 times negative 1, where's the answer? Back here. So multiplying by a negative is a 180-degree turn. Do you guys understand? If I have 1, multiply by negative 1, now I'm over there. Now I'm facing the other way. Does that kind of make sense? So let me try again. So if I multiply 2 by negative 3, 2 times 3 is 6. The fact that I multiplied a negative makes it go over there. Now it's negative 6. Okay, so you can think of multiplying by a negative as putting it on the opposite side of the number line, which actually relates to why I've got to flip the inequality symbol also. That's sort of how I explained that. How are we doing so far? So the full truth of imaginary numbers is that this is not a complete number line. This is the real number line, but it's not complete. I have to also include the imaginary number line, which would be like this. So multiplying by negative 1 is a full turn. Doesn't it kind of make sense that to do a half turn, I want to do half of negative 1 multiplicatively, so I got to do the square root of negative 1. So multiplying by I, what's 1 times I?